Go. Hello guys. Hello Mr. Eric, Mr. Ryan, alright? Okay, so let's look at this mess. A to the power of A equals 2 to the power of 2048. A is an integer, obviously, okay? We say A is integer, is integer. Okay? Integer bigger than 0, okay?
Obviously.
Obviously bigger than 0, okay? Bigger than 0. A is bigger than 0. Okay? So have a guess. What's A? Is it 1?
2009.
Is it 1?
Definitely
No.
not.
2?
Definitely not.
3?
Definitely not.
Obviously, because it's too small, yeah? How about 8? Definitely.
Definitely not.
Okay. How about 100? We don't know, yeah? We don't know, right? Okay, so yeah. This is a very huge number. It means that we multiply 2048 times, yes? 2 times 2 times 2 times 2. How many times of 2? 2038 times.
With
Okay.
E equals 4096.
No,
4096. That's 2 times 2048.
that's right. But no, because that means that they are, this means 2 times 2 times 2. How many of 2? 2048 2. Okay, that's the power. 2 to the power of that. Okay, so let me show you. A to the power of B times C. Right? What does it equal? It's actually equals A to the power of B then to the power of C. Okay, how can I interpret this? 3 to the power of 2 times 3, okay? This is equal 3 to the power of 6, right? Yeah? Yeah? It's actually equals to 3 to the power of 2 to the 3. So this equals 9 to the power of 3. Is it the same? Like 6, 3 together, times together. Yeah, that's 6 of 3. 1, 2, 3, 4, 5, 6. How many 9s? 3 9, yeah? Yeah, so these two here, these two here, these two here.
27.
Yeah? Got it? You get it? So
And then
A to the power of B times C equals to, we can do these two together and then to the power of C. Okay, so how does that help us? How does that help us? Look, 2 to the power of 2048 is equals to 2 times 1024. Look at this. Yeah?
Yeah.
So if I do this together, that equals 4 to the power of 1024, right? So this thing is equal to this thing. Okay, so keep going. This equals to what? 1024 equals 2 times 515, right? 512, right? So if I do this together, that will be 16 to the power of 512, right? Yeah? Okay, so can you get the next one? Next one. So this is equals to 16 to the power of 2 times 256, right? Yeah? So we can do these two together. 16 times 16 equals what? Come on, it's there. It's on there.
2048.
16 times 16.
256.
Yeah, okay, so it's 256 times to the power of 256. Okay, what's A?
256.
Exactly. Okay, that's how we get it, yeah? That's mathematics. But one of the important things today is this. A to the power of B times C equals A to the power of B. We can do this together and to the power of C, okay? Yeah? Yeah? Very beautifully. We get it, yeah? So we know the A is 256 to the power and these two numbers are equal. It's a very huge number. We don't know. Yeah? Okay, so the other way, this is mathematics. We can ask computer to find this value, yeah? We can ask computer to brute force this, right? Yeah, but brute force, you know,
So
you don't know the
256 times 256 times 256.
250. Okay, so look, A to the power of A equals this. So A must be smaller or equal than 2048, right? Obviously, yeah. If this is 2048 is obviously bigger than 2 to the power of 248, right? So the upper bound is 2048. So we can just ask computer to search the A from 1 to 2048, right? Yeah? Or we can binary search. Yeah? You remember what's binary search? Guess the number 1 to 100. Guess the number. You always find the middle one.
50.
50. If I tell you the number in my mind is bigger than 50. So
Okay, then 75.
yeah, you always find the you got it. You search in the upper bound. If I'm saying okay, the number in my mind is smaller than 50, you search in the lower half, right? Always cut in half, okay?
And
So
then also at 25.
yeah, exactly. You always find the one in the middle. So for the one in linear, so for A in range, and that's range 1 to 249, the 248, 2048. Then if A times A, okay, A times A, okay, that's to the power, right? We talk about that. A times multiply B is the same as A to the power B, and then you can write mass the power AB. This is the same thing, yeah. Okay, if A multiply A equals 2 multiply to 2048, then we return A, right? Easy. This is the linear search. Linear. Okay, but we can do it binary search. So the lower bound is 1, right? Lower bound is 1. Upper bound is 2048. Binary search. Why the left and right do not meet? Okay? Yeah? Why the left and right, the window, look at left and right do not meet. A smaller equal than right. Then middle equals A plus R divided by 2, right? Divided by 2. Okay? Find the middle, okay? Or you can do this A plus R, shifty 1. This is the same thing. Okay, mm equals m multiply, let's do the power m to the power of n. Okay? Then if mm equal 2 to the power of 2 multiply to the power of 2048, then we find this number, return mm, right? Okay, now you tell me, if this number mm is bigger than this number, okay, bigger than 2 to the power of 2048, right? So look, if this number is bigger than that, so what does it mean? Look here, this is the middle, yeah, this is the middle. Alright, if this number to the power, we are guessing this m now, but if this m to the power of m is actually bigger than 2 to the power of 2048, so which half is this?
Then it has to be
Left or
the other.
which one? Left or right? Come on. If this number m to the power of m is bigger than 2 to the power of 2048, so
Right.
this number is bigger than this.
Left.
So we should look for the left, right?
Yeah.
So for the left, it will be R will be equals to m minus 1. As look, if it's smaller than that, so where should we look for? Which half? If this number right, so as what? As what?
Or else.
Look, this is L, this is R. So
That equals m plus 1.
where that exactly? I want there to meet. Yeah. Okay, got it? Binary search. What's the time complexity? Usually. O log n, yeah. O log n. Okay? But here, look, because we already know the lower bound, upper bound. So in this case, the time complexity is O1, okay? You're right, yeah? But do you understand the reason behind it?
Yeah.
You sure? Okay. Why is it O1? Because look, the lower bound and upper bound is
Because
already,
n
we
equals
already
1 to
know.
21.
We already know the maximum, the search space is between the 1 to 2 and 2048, right? But you are also right. What I meant is that when this, when they are n, generally n, you do this log n, okay? Yeah. Log 2 2048. What's this number? 2 to the power of x equals 2048. How many? What's x? 2 to the power of 10 equals 1024. What's x? How many more? 1024 times what equals 2048?
2.
Okay, so how many more 2's I need to multiply?
2.
How many more 2's?
1.
Yeah, so 2 to the power of what equals 2048?
11.
Exactly. Okay? And that's it for today. Bye bye.
250.
Bye.
Bye bye. Do a little bit dancing. Bye bye.
Wait. Bye.
Okay, that's it.